Hi, in this lesson we're going to be learning about multiplying rational expressions. Now, what are rational expressions? They're basically just fractions where you have a polynomial in the numerator and a polynomial in the denominator. Okay, so if you look at the word rational, it has the word ratio built into it, and ratio just means a fraction is really all it means. So we're dealing with fractions, and in particular they're fractions with a polynomial in the numerator and a polynomial in the denominator, which is, just a specific type of fractions. Now, how do you multiply fractions? You multiply fractions straight across. Okay, so when you're multiplying rational expressions, which are fractions, you multiply straight across. Straight across. So that does not mean you cross multiply. Rather, it means that you're going to multiply the numerators directly across and then the denominators straight across. Okay, so for example, if you have A over B times C over D, to multiply it straight across, you're just going to get AC over BD. Okay, so as you can see, you're just multiplying the numerators and multiplying the denominators. Okay, so they're actually very straightforward, and we already talked about how to multiply fractions before, so hopefully you remember this from an earlier lecture. But in this lecture, we're going to also be dealing with some more complicated fractions. And when we simplify those, we're going to end up needing to factor and using the rules of exponents. Okay, so these are going to be a little bit harder than some of the fractions we dealt with earlier in the course, and that's why they're called rational expressions. Okay, so example. Let's do an example. Example, multiply. So they just say multiply. But even if they just say multiply, you also need to simplify. Okay, so multiply, and then I'll put simplify in parentheses. Simplify if possible. Now, sometimes they're nice, and they actually say that in the directions. They'll say simplify if possible. But other times they're not nice, and they won't say it. Okay, so I put it in parentheses because they don't always say that. Okay, so for our first example, example number 1, we're going to be multiplying 21x over 3. Okay, 21x over 3 times x to the 7 over 7x squared. Okay, so 21x over 3 times x to the 7 over 7x squared. Now, once again, like I was saying above, you multiply straight across. So that means you multiply the numerator and you multiply the denominator separately, and then you simplify. Okay, so for this one, multiplying the numerators, we get 21x times x to the 7. Okay, 21x times x to the 7 in the numerator. And then in the denominator, we have 3 times 7x squared. Okay, so we're just multiplying the numerator and the denominator. Now in the numerator, x times x to the 7 is going to be x to the 8th. And the reason that's true is using your rule of exponents. Remember, if you're multiplying exponentials with the same base, you actually add the exponents. So on the top there we have x to the 1 times x to the 7, which is going to be x to the 1 plus 7. Okay, so we have 21 times x to the 1 plus 7. So we're adding those exponents And if you don't remember your rules of exponents, I recommend that you watch my earlier video when I talk about the rules of exponents. But basically, you're multiplying exponents with the same base, so you add the exponents. Okay, and then in the denominator, 3 times 7 is 21. So in the denominator, we have 21x squared. And in the numerator, 1 plus 7 is 8. So we actually get 21x to the 8 divided by 21x squared. Okay, and then what do we have to do next? Well, we have to simplify this a little bit more. So first of all, notice that we have a 21 on the top and the bottom. So those just cross out. So we can just cross out the 21s. And then if you're dividing exponentials with the same base, you subtract the exponents. So here, x to the 8 divided by x to the 2 is going to be x to the 8 minus 2. Okay, and the order in which you subtract does matter. So when you're dividing or subtracting, the order is going to be top to bottom for dividing and left to right for subtraction. So because we had an 8 on the top and a 2 on the bottom, the 8 came first and the 2 came second, left to right. So top to bottom, left to right. So we got x to the 8 minus 2 is x to the 6. Okay, and that's going to be our final answer. So our answer is x to the 6. Now, what are the rules of exponents I used there? Well, up here, we had x times x to the 7. So the rules of exponents that I used for that one, let me write them over here. Rules of exponents. Well, first of all, notice that I wrote x as x to the 1. So I wrote x as x to the 1, because remember, a variable is the same as that variable to the first power. Okay, so the first rule that we used here was x equals x to the 1. Okay, so that was our first rule of exponents. The second rule of exponents we used was when we had x to the 1 times x to the 7. If you're multiplying exponentials with the same base, if you're multiplying powers with the same base, you add the exponents, or you add the powers. Okay, so we got x to the 1 plus 7 is x to the 8. So in other words, we have, if you have x to the m times x to the n, if you're multiplying exponentials with the same base, you add the exponents. So that's going to give you x to the m plus n. So that was the one we used to go from here to here. X to the 1 plus 7 is x to the 8. Okay, and then the last rule of exponents we use is if you're dividing exponentials, you subtract the exponents. So if you're dividing powers, you subtract the powers. Okay, so the third rule is if you have x to the m divided by x to the n, if you're dividing, you subtract the exponents. So that's going to give us x to the m minus n. And here the order does matter. Top to bottom, left to right. So that's how we got from x to the 8 divided by x to the 2 to x to the 8 minus 2, which is x to the 6. Pretty cool, huh? So that one hopefully isn't too bad, because we've done examples like this one before. So if you need more of a refresher, watch my video on the rules of exponents, because I talk about this. Okay, so I wanted to do one more like this, but one that's a little bit harder. Okay, so for example number 2, we're going to take a look at a little bit harder problem. It looks a lot harder, but it's actually not that bad. So this one is negative 2f to the 4, negative 2f to the 4, g to the 3. Okay, that's a numerator of a fraction. And then the denominator of our fraction is 6 f to the 4, g to the 6. Okay, so we have negative of the fraction 2f to the 4 g to the 3 divided by 6f to the 4 g to the 6th times g to the 5. So there's a lot going on here. But basically we have minus of a fraction 2f to the 4 g to the 3 over 6f to the 4 g to the 6, and then we have the fraction times g to the 5. Now the first thing I want to point out to you here is we do have a lot going on, and we also have two different variables here. So it's important to remember that you can only combine like variables, so you can only combine powers if they have the same base. Okay, so here, what that means is we can combine the g's with each other and we can combine the f's with each other, but we can't combine the f's with the g's because they're different letters. Okay, they're different variables. So what we can do though is we can kind of break this down into little parts. So the first thing I want to do is deal with this g to the 5 out here. So remember, if they don't write the denominator is automatically 1. Okay, so this denominator over here is actually 1. So I'm going to rewrite this as g to the 5th divided by 1. Okay, g to the 5th divided by 1. All right, and why did I do that? Well, remember, we're multiplying fractions, and the way you multiply fractions is you multiply straight across. So we multiply the numerator, and we didn't have a denominator, so if they don't write the denominator, it's automatically 1. So that's important to know. That's why I want to talk about that. And then now that we're going to multiply straight across, we're going to get negative 2f to the 4 g cubed times g to the 5th all over 6f to the 4 g to the 6th times 1. And of course, any number times 1 is just a number, so we don't really need to write the 1 on the bottom. And there's not much else to do in terms of the multiplying part. So now we go on to simplify. So remember, even if it just says multiply in the instructions, you still need to simplify. That's important to remember. Okay, so so for simplifying here, like I said, any number times 1 is just a number. So we can go ahead and get rid of this 1 down here. It's not doing anything. Now in the numerator, we can combine the g to the 3 and the g to the 5. So if we combine the g to the 3 and the g to the 5, because we're multiplying up there and they have the same base, we add the exponents. So that's going to give us g to the 3 plus 5, okay, which is of course g to the 8, because 3 plus 5 is 8. So up there we have g to the 8, but don't forget we still have the rest of this stuff. So we still have negative 2f to the 4, and now we have a g to the 8 on the top, and then on the bottom we still have a 6f to the 4 g to the 6. Alright, so we took care of the numerator, so the numerator has been simplified, and now we're ready to go ahead and divide the top and the bottom. And remember, once again, the way you do that is you kind of break it into parts. So the first thing we need to focus on is the 2 and the 6. So those are constants, and we're looking for a common factor that we can divide by. So we can divide 2 and 6 by 2. So let's go ahead and do that first. So if we divide the top and the bottom by 2, we're going to get negative 1 over 3. Right? Because 2 divided by 2 is 1, and then 6 divided by 2 is 3. Okay, and that takes care of the constant. So let's move on to the f. So looking at f to the 4 divided by f to the 4, because these are exactly the same power, you can just cross them out. If you have the exact same thing on the top and the bottom, just cross it out. Okay, so you can cross these out. So that takes care of the f's. And then for the g's, because we're dividing and they have the same base, we can go ahead and subtract the exponents. Okay, so if we subtract those exponents, then we're going to wind up with g to the 8 minus 6 in the numerator. Okay, so we have g to the 8 minus 6 on the top. And by the way, when you're subtracting exponents, you always subtract wherever the larger exponent is. So here the larger exponent is in the numerator. So that's why we're doing g to the 8 minus 6 up in the numerator. If the larger exponent was in the denominator, for example, if the 6 and the 8 were switched, then you would actually be doing g to the 8 minus 6 on the bottom. So you'd be doing it in the denominator. But here, the larger exponent's in the numerator, so we're subtracting up in the numerator. Okay? And then after all that, we just get g to the 2, because 8 minus 6 is 2. So we have negative 1/3 g squared. And the way most people would write that is they would write the negative 1/3 first, and then they would write g squared. Okay? Or another way you could write it, actually the way they write this on my math lab, is they actually write it, they move the g squared up here, and they multiply it times 1. So they actually write it as negative g squared over 3. But remember, that's the same thing as negative 1/3 g squared. Okay. So that's about as hard as your first type of problem gets on your homework. Now there's another type of multiplying problem where we have more than one term. And these are also important. They have the same instructions, but some of them say find the product. So just in case you don't know what find the product means, if they say find the product, what does the word product mean? Well, the word product literally just means multiply. Okay, so product just means multiply. So just keep that in mind. So if they're asking you to find the product, they mean multiply, but as always, even if they don't say it in the instructions, in math, it's expected that you simplify your answer. So even if they just say find the product, that means multiply and simplify. So all of these mean that you need to simplify them after you multiply. And the same thing goes for dividing, which we'll be doing in a later video. Okay, but for number 3, we have x over 7x minus 14, okay, times x squared minus 2x all over 9. Okay, so x all over 7x minus 14 times x squared minus 2x all over 9. So how do we combine all this stuff? Well, when you're multiplying, you multiply straight across. But what's new about this problem is on this top right corner and then also on this bottom left corner, we see that we have more than one term. So if you're trying to multiply or divide something that has more than one term, always put parentheses around things when they have more than one term. It's just a general rule, not just when you're multiplying, not just when you're dividing. If you have something with more than one term and you need to plug it in or you need to multiply or divide, any of those things, put parentheses around it. Okay, so here we're going to put parentheses around the 7x minus 14 and the x squared minus 2x. Whenever it has more than one term, put parentheses around it. Okay, and then the rest of the problem is kind of similar. So we're going to multiply straight across. So we're going to multiply the numerator and the denominator separately. So in the numerator we have x times x squared minus 2x. And then in the denominator, we have 7x minus 14 times 9. Okay, so x times the quantity x squared minus 2x over the quantity 7x minus 14 times 9. Now I said the rest of the problem is pretty similar in that when you're multiplying, you multiply straight across. But there is something new here. We can simplify this, but we're going to have to factor. Factoring is the standard way to simplify these. So we need to factor everything. Okay, so factor completely. All right. Then we're going to cross out any common factors. Then cross out any common factors. Okay, so like in the numerator, we see that we can factor out the GCF, which is x. Okay, so in the numerator we have x times the quantity x minus 2. So what did I do there? I factored out the GCF, which was an x. Okay, see I circled it in red there. So I factored out that x, and I was left with an x minus 2. So in the numerator now we have x times x minus 2. Now what can we factor in the denominator? Well, in the denominator, we have 7x minus 14, and we can factor out a 7. Right? Because 7 is the biggest number that goes into both 7 and 14. So if we factor out a 7 in the denominator, we have 7 times x minus 2 times 9. Okay? And when I say factor completely, I mean you also want to combine stuff. So we kind of want to combine stuff a little bit more here. So in the numerator, we have x times x is x squared. So we have x squared times x minus 2 in the numerator. And then in the denominator, 7 times 9 is 63. So in the denominator, we have 63 times x minus 2. Okay, and then what's going to happen next? Well, this is the fun part. Now that we've factored everything, now we can just cross out any common factors. So now we can cross out the x minus 2, and we're just left with x squared on the top, and then 63 on the bottom. And that's actually going to be our answer, okay? So our answer is going to be x squared over 63. Pretty cool, huh? So you start with a big complicated thing, and then when you simplify it, it gets down to a pretty short and easy to write answer, which is kind of nice. Okay, so I think you're going to be good for the first couple of problems there. Now there are some harder ones that I wanted to show you. So that one we just did was example number 3. Okay, so we just did example number 3. So let's take a look at example number 4. So for example number 4, we've got something that looks a lot more complicated, and it is more complicated. So for this one we have r plus q, quantity to the 6th power, divided by 3r minus 3q, okay, times 3r divided by r squared plus r cubed. Okay, so we have r plus q, quantity to the 6th power, divided by 3r minus 3q, times 3r over r squared plus r cubed. So what's harder about this one is there's just more going on. There's powers, there's this r plus q to the 6. A lot of people wouldn't be sure what to do here. Now one thing you wouldn't want to do is you would not want to multiply out r plus q to the 6, and you're not allowed to distribute the 6th power. There's no rule that says you can distribute a power when it has more than one term. Okay? But what you can do is, just like on the last problem, we can put parentheses around anything that has more than one term. Then we can multiply straight across. Okay, so what's the stuff that has more than one term here? Well, the r plus q to the 6 already has parentheses, so we're good there. The 3r minus 3q has more than one term, so we put parentheses around that one. And then on the bottom right, r squared plus rq, that also has more than one term, so we put parentheses around that one. Okay, and then how do we combine all this? We multiply straight across. Okay, so we have the quantity r plus q, quantity of the 6th power, times 3r on the top. And then in the denominator, we have the quantity 3r minus 3q times the quantity r squared plus rq. Okay, so basically we have a lot of stuff going on here, and when you're copying this down for this kind of work, make sure you check and make sure you wrote everything correctly, because it's easy to write something wrong when there's this much going on. So some people don't like this kind of thing in math when it gets really complicated, and I can understand that. But it's not as bad as you think. So for the r plus q to the 6, we're just going to leave that the way it is. But we're going to go ahead and factor this stuff on the bottom. So on the bottom left, we notice that the GCF that we can factor out here is actually going to be a 3. Okay, so on the bottom left, we can factor out a 3. All right, and then on the top, we're going to leave it as r plus q, quantity to the 6th power, times 3r. On the bottom, I factor out a 3, and I'm left with r minus q. Okay, and then on the bottom right, we can also factor out the GCF there. So we see that we have an r in common. So if we factor out an r on the bottom right, that's going to give us r times a quantity r plus q. Okay, so all I'm doing there is I'm factoring everything, and on the bottom left and on the bottom right, I'm factoring out the GCF. Okay, now's the fun part. Now we get to cross stuff out. So first of all, I notice there's a 3 on the top and a 3 on the bottom, so I can cross those out. And then I notice there's an r on the top and an r on the bottom, so I can cross those out. Now for the r minus q, I can't cross that out with the r plus q on the top. But for the r plus q, those are the same thing, so we are going to be able to cross these out. But they're really exponentials. They're actually powers with the same base. So what we're going to do there is we're going to be subtracting the exponents. Because we're dividing, we're going to subtract the exponents. So on the bottom right corner, that's r plus q to the 1st power. And when we divide those, we subtract the exponents. So we're actually going to have r plus q to the 6 minus 1 on the top. R plus q to the 6 minus 1. Now how did I get that? Well, these, even though they have two terms, they have exactly the same base. And because we're dividing, we subtract, and the order matters, top to bottom, left to right. So that's r plus q to the 6 minus 1 on the top. And then we still have an r minus q on the bottom, but because it's not exactly the same thing, we can't combine it with the r plus q on the top. Okay, so we just leave it as r minus q. All right, and then we all know that 6 minus 1 is 5. Okay, so that on the top, we're going to have r plus q, quantity to the 5th power. And then on the bottom, we have r minus q. Okay, and that's just r minus q by itself, so I don't need parentheses around that one. So when you're plugging in or multiplying or dividing, you do want to put parentheses around something with more than one term. But in your final answer, if you have more than one term and it doesn't have anything multiplied or divided by or raised to a power, we can just leave that as r minus q without the parentheses. Okay, so the parentheses are just a tool you need to put in when you're multiplying, dividing, or raising to powers. Okay, So now we're all done with this problem. So this is going to be our answer. So we have the quantity r plus q, quantity of the fifth power, all over r minus q. And we can't simplify that anymore, so we box it. That's our answer. Okay, and then I just wanted to show you two more examples of multiplying rational expressions. Now these do get quite challenging, but they're not challenging if you know what you're doing. So let's take a look at example number 5. Okay, example number 5. So for this one, we have two fractions multiplied together as usual. So the first fraction is x squared minus 9 all over x squared minus 2x minus 3. Okay, and then this is times the second fraction. So this is times x plus 1 all over x. Okay, so we have two fractions multiplied together. X squared minus 9 all over x squared minus 2x minus 3 times x plus 1 all over x. So just like before, if you have more than one term, you need to put parentheses around it. Okay, so we've got the x squared minus 9. That has more than one term, so we put parentheses around it. Top right, we have x plus 1. That has more than one term, so we put parentheses around that one. And then bottom left, x squared minus 2x minus 3 also has more than one term, so we put parentheses around that one. Okay, and then when you're multiplying, you just multiply straight across. So I'm going to be lazy here, and instead of having to rewrite the entire thing again, I'm going to be lazy and just combine this. So I'm going to rewrite this multiplication as a single bar in the middle, and then we multiply straight across. Okay, that's really all multiplication is. You just multiply straight across. Now the hard thing about this problem is all the factoring we have to do. So top left, because this is a binomial, it has two terms. The way you factor something with two terms, when you have a square minus another square, is the difference of squares. Okay, so this top left is going to be the difference of squares. That's the one we learned earlier in this course about how to factor a binomial. So that one says x squared minus y squared equals x minus y times x plus y. Okay, so for x squared minus 9, we can rewrite that as x squared minus 3 squared, because remember 3 times 3 is 9, so 3 squared is 9. Okay, and in particular, the difference of squares says x squared minus y squared, so here it's going to be x squared minus 3 squared equals x minus 3 times x plus 3. Okay, so that top left is going to factor as x minus 3 times x plus 3, using the difference of squares. Okay, so far we have top left is x minus 3 times x plus 3. And then top right, we still have x plus 1. Okay, and then on the bottom left, x squared minus 2x minus 3. Well, that's actually a trinomial. It has 3 terms, so we're going to factor using the x method. Okay, so I'll circle that in green. This one we're going to factor using the x method because it has 3 terms. So on the top of the x, we write the last term, which is negative 3. And then on the bottom of the x, we write the second term, which is negative 2. Okay, and then we want two numbers that multiply to negative 3 that add to negative 2. So those winning numbers would have to be negative 3 and positive 1. excuse me, because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. Excuse me, I need a cough. I need to pause this. Okay, I don't have COVID, I just had the vaccine, and I'm having a bad reaction to it. That's why I'm coughing. Okay, but it was way worse yesterday. I'm doing better today. Alright, so what we got here is x squared minus 2x minus 3 is going to factor as x minus 3 times x plus 1. So on the bottom left, we actually have, this is going to be x minus 3 times x plus 1. So that goes on the bottom left. X minus 3 times x plus 1. And then on the bottom right, don't forget, we still have an x. Okay, so we still have an x on the bottom right. Okay, so far we have x minus 3 times x plus 3 times x plus 1 all over x minus 3 times x plus 1 times x. And then stuff's going to cancel out now, finally. So the x minus 3's cross out, the x plus 1's cross out, but we can't cross out the x plus 3 and the x because they aren't exactly the same factor. Okay, so that's actually going to be our answer, is going to be x plus 3 on the top and x on the bottom. Okay, so we get x plus 3 all over x. And that is our final answer for that problem. Okay, so there's one more example I wanted to do. And this is definitely the hardest one on your homework. Okay, mostly just because it's big. It's just a really big problem. It has a lot of stuff going on. Okay, so example number 6. Example number 6 is x squared plus 9x plus 14 divided by x squared plus 6x minus 55 times the next fraction is x squared minus 2x minus 15 all over x squared plus 4x plus 4. Okay, so we have x squared plus 9x plus 14 all over x squared plus 6x minus 55 times x squared minus 2x minus 15 all over x squared plus 4x plus 4. So the scariest thing about this problem is just writing it down. I know it looks scary, or at least it looks like awful, because there's just so much going on. But remember, if you have more than one term, you put parentheses around it. So for starters, we're going to put parentheses around the top left, the top right, the bottom left, and the bottom right. And then when we're multiplying, we just multiply straight across. So I'm going to be lazy and just rewrite this as a single fraction where we're multiplying on the top and the bottom. Now the way you want to factor this is each of these is a trinomial, so you want to use the x method for all 4 of them separately. Okay, so let's start with the top left. So for the top left, using the x method for the top left, let me use a color here. So for top left, I'll do that one in red. So using the x method, on the top we're going to have a 14, and on the bottom we're going to have a 9. Okay, so that one is going to factor as, let's see, 2 times 7 is 14, but 2 plus 7 is 9. So the numbers are going to be 2 and 7. Now for top right, I'm going to go ahead and use black. So for top right, on the top of the x, we're going to have negative 15. And then on the bottom of the x, we have negative 2. Okay, so what are two numbers that multiply to negative 15 but add to negative 2? Well, we have negative 5 times positive 3. So negative 5 times 3 is negative 15, but negative 5 plus 3 is negative 2. Okay, that's for top left. And now for bottom left, sorry, that was for top right. I meant to say top right, but I said top left. So here in red, we have top left. In black, I did top right. And then for bottom left, I'm going to do that one in blue. Okay. So for bottom left, factoring that one, we have negative 55 on the top of the x. Okay, so negative 55 on the top of the x, and then 6 on the bottom of the x. So we want two numbers that multiply to negative 55, but add to positive 6. So I'm going to say positive 11 and negative 5. Okay, so positive 11 times negative 5 is negative 55, but positive 11 plus negative 5 is positive 6. And then for bottom right, I'll go ahead and do bottom right in green. Okay, so in green, I'll do bottom right, once again using the x method. On the top of the x, we have a 4, and then on the bottom of the x, we also have a 4. So we want two numbers that multiply to 4, and two numbers that also add to 4. So in case you were wondering, that's going to be 2 and 2, because 2 times 2 is 4, and 2 plus 2 is also 4. That's what we learned in class today. 2 plus 2 is 4. Okay, and then from here, we've factored. So now we're going to go ahead and rewrite all these as things that we've factored. So for top left, we have x plus 2 times x plus 7. For top right, we're going to have x minus 5 times x plus 3. Okay. For bottom left, we have x plus 11 times x minus 5. And then for bottom right, we have x plus 2 times x plus 2. Okay, and thankfully, we've actually factored all this. Whew, that was a lot of work. Okay, and then all we have to do here is cross out any common factors. So things that cross out here is, I see there's an x plus 2 on the top and the bottom. Those cross out. There's also an x minus 5 on the top and the bottom. Those cross out. But then beyond that, nothing else crosses out. Okay, so we're going to be left with, on the top, we still have x plus 7 times x plus 3. And then on the bottom, we have x plus 11 times x plus 2. And now that we've done all of that, because nothing else crosses out, this is going to be our answer. So it's not the cleanest answer. I know it's kind of complicated, but it is simpler than what we started with. Okay, so x plus 7 times x plus 3 all over x plus 11 times x plus 2. All right, and that's as hard as your homework gets for the multiplying. Okay, and then I also wanted to, since I'm on a roll here, I'm also going to do dividing rational expressions on this same video. I was going to make a separate video, but I'm kind of spontaneous sometimes, and right now I think I decided I just want to combine them all into one video. So let's continue here, but the next thing we're going to be doing is dividing. Okay, so to divide fractions, In other words, to divide rational expressions is what we're focusing on here, which are just fractions with polynomials on the top and the bottom. To divide fractions, flip over the second fraction and multiply straight across. Flip over the second fraction and multiply straight across. Okay, in other words, dividing fractions is almost the same thing as multiplying fractions. It's just you have an extra step where you flip over the second fraction before you multiply. But other than that, it's exactly the same as multiplying fractions. Okay, so let's see an example of that. Okay, example. For this one, I'm just going to jump into one of the harder ones since we've already seen a lot of multiplying fractions. So let me jump into a later problem. And I think we'll just do one of these. So the instructions here are to divide. Okay? Divide. Okay? So what we have here is a squared minus b squared all over a plus b divided by a over a squared plus ba. Now this is about as hard as your homework gets for the whole dividing fractions business. And again, I'm only going to do one example because these are actually very similar to what we've been doing. So notice we have the division symbol here instead of the multiplication symbol. And even though they just say divide, they also want you to simplify. Okay, so what do? Well, as always, you put parentheses around anything that has more than one term. Okay, so for top left, parentheses go around that. Bottom left, parentheses around that. Bottom right, parentheses around that. Okay, so after we do all that stuff, the next thing we have to do is, because we're dividing, we need to flip over the second fraction, and then we need to multiply straight across. Okay, so flipping over the second fraction, that's the only thing that's different about dividing. Other than that, it's basically just multiplying. So like I said, you flip over the second fraction only, don't flip over the first fraction, and then you multiply straight across. Okay, so here, the first fraction is still going to be a squared minus b squared over a plus b. But now the second fraction is going to be upside down. So now we're going to have a squared plus ba all over a for our second fraction. And now we're multiplying. But remember, it says multiply straight across. And when you multiply straight across, that means you combine these two as a single fraction. And you just go ahead and multiply straight across. Okay? Okay. Alright, so the rest of the problem should be pretty similar to what we did earlier. So now we just need to factor stuff. And this one isn't too bad to factor. So with the top left, we're going to go ahead and factor the top left, the a squared minus b squared, as the difference of squares. So remember, if you have two things subtracted from each other, they're both squares. That's going to be the first thing minus the second thing times the first thing plus the second thing. So here that's going to factor as a minus b times a plus b. Okay? So a minus b times a plus b. And then for the top right, we can factor that one by factoring out the GCF. Okay, so here we can see that the GCF is going to be A. That's something in common that we can factor out. Okay, so on top right, we factor out an A, and we're left with A plus B. Now in the denominator, there's nothing to factor. Okay, so in the denominator, we're just left with A plus B times A. So what's going to cancel out now? Well, we can see on the top and the bottom we have an A plus B right there. And then we also have an A in common. Now, is there anything else to cancel? Well, no, because we crossed out everything in the denominator. So you would think that the answer would be A minus B times A plus B. And then we don't need to write the denominator because now the denominator is actually 1. Because if you cross out everything, there's still a 1 left over. But remember, any number over 1 is just a number. So we can just not write that 1 in the denominator. So you would think that the answer would be A minus B times A plus B, right? But for some reason on this problem, they actually multiply it out at the end. Okay, so at the very end here, for whatever reason, my math lab actually multiplies this out. Okay, so using FOIL, first, outer, inner, last, we get A times A is A squared plus AB minus AB minus B squared. So the plus AB and the minus AB, those cancel out because they're like terms. And then so that brings us to our answer, which is A squared minus B squared. Okay? And you do have some other problems on your homework that are dividing rational expressions. But remember, those are going to work a lot like the multiplying rational expressions. It's just that you flip over the second fraction first before you multiply. And then you multiply straight across and you simplify. So I think you should be good there. I think you're good for your whole homework now. Thanks for watching.